Beautiful Thursday morning it is. The sun is shining down, the sky is blue. Second day of gorgeous weather after that rainy period that we had. The sun is radiating energy down on my face and I love it. Okay, let's talk about this worksheet identifying heat transfer. Obviously we gave you the example of the pot. So I'd like to start with the campfire. Okay, so as far as radiation goes, the fire is transmitting thermal energy through the process of radiation. Heat is moving through the air in electromagnetic waves, mostly infrared waves and visible light, emitted by the fire due to its temperature. I think you've learned in the con video that the particles got to get moving so fast and then boom. All right, conduction is taking place wherever the infrared rays from the fire come in contact with a solid. The thermal energy is transferred into the solid through the process of conduction. So in this picture, there's conduction taking place in the marshmallows, the marshmallow holders, and the side of the human beings facing the fire, as well as the ground around the fire. You know, you guys have all experienced that. You're sitting around a fire, and I mean, it just feels great, that radiation that comes on you. But you notice that your backside stays cold. That's because the waves are coming at you, and they only hit the side that's facing the fire. All right, in our next one, we have a beach scene, one of my favorite places to be, but I haven't been to in a long time. The sun is obviously it's radiating that thermal energy through space towards Earth in the form of electromagnetic waves emitted by the reactions taking place on the sun's surface. Those are traveling down through us, and kind of like me right now, my face is kind of getting warm, even though it's kind of cool out here right now. My face, top of my hat, my shirt, it's kind of getting warm because I am it's getting bombarded with those sun's rays. So in the picture then, if you look at that, the chair, the sand, the umbrella, if I was sitting there, anything that is getting hit is absorbing those energies, and it's conducting the sun's thermal energy and getting the particles to move a little bit faster. And convection happens because of the Earth's surface being heated up. The air above it gets heated up, and you know what happens when it gets heated up? The molecules move farther apart, they become less dense, and then they rise, okay? At a beach scene like that, and I personally have been on beaches a lot down in Florida in spring break time, and this happens. You're sitting there, like this time of the day, you get down there about 9 o'clock or so, and you're sitting there, it's kind of cool, it's really calm, and man, you're just enjoying it, everything's cool, and then all of a sudden, the breeze just picks up from the ocean, and it's like, whoa, what's going on? You know, the waves aren't increasing at all. Well, what it is as that air gets heated up and it rises, the cooler air off the water comes and takes its place. And at night, I didn't say that in my writing here, but in the nighttime, the opposite happens. As the land cools, the water is warmer, so the air above the water is rising, and then the breeze will go out onto the ocean. Pretty cool phenomenon that takes place on our coastlines. The next one is a solar oven. So we've got the solar oven. There's a piece of glass over it. You can't really see it over the top of that, lined with aluminum foil, and there's a black kettle inside. So again, we have the sun, electromagnetic waves coming down, and the aluminum foil is reflecting that light down inside there. And then it gets bounced around inside there, and it hits the glass, and it goes back down. So it's kind of getting trapped in there, and it's hitting the black kettle. And that is where conduction takes place. If you would feel the aluminum foil inside, the aluminum foil would be cool, but the kettle, because it's steel and it's black absorbs all that energy. And then the conduction takes place, and then whatever you happen to have inside of that kettle would start to get warmer and warmer and warmer too through conduction, because the the energy would go through the steel or whatever that kettle's made out of into the food stuff. And then convection's taking place inside of that box as the air gets warmer because of the thermal energy that's being trapped in there. Again, the molecules are expanding, they rise, they hit the glass, they come down, and then eventually the air heats up inside there, and if you put a thermometer inside there, you'll see that it gets really hot. The next one is a solar heated pool. I personally have this set up right here on my, well, I can kind of show you maybe. Can you see my pool back there? Yeah, well, my pool back there, I don't have it set up yet, but I have it in the garage. Solar radiation from the sun, same deal. Then the conduction takes place wherever the sun hits, so the grass is getting warm, the filter's getting warm, the pump's getting warm, and then those solar panels are black on purpose because they absorb the heat. And there's tiny little tubes running through there, and as the water gets pumped through there, the thermal energy that is in that black plastic through conduction goes into the water and then thus into the pool. Convection's taking place because the water molecules are getting heated up. They're rising, and then they cool off and they fall, and then, you know, eventually the pool will raise in temperature. On a good sunny day, I can raise the temperature in my pool, which is like 13,000 gallons, 4 or 5 degrees, which is that's a lot of warmth. Okay, and the next one is we have, this is called an infrared heater, and they work a little differently. There's no fan inside there. The electricity is converted into some super hot metal, and then that radiates through the infrared waves that come off of there. And the way this kind of heating works is they usually mount it on the ceiling. When I worked in the body shop, they would have these heaters on the ceiling. You would feel no air movement. The way it worked is the thermal energy would strike every solid in the place, the floor, the cars that were sitting in there, and through conduction, those would slowly get warmer and warmer, and then, because all of those solids in there were getting warm, the air above them started getting warm, and then you had your convection. As the warm air rose, cooler air took its place, got warmed, and you just had this turning inside there. And it wasn't like you could feel it, but it was just the air was turning, and eventually it got totally warm in there without one bit of a fan blowing it around. It was pretty cool, because you would walk in there and it would feel like really warm because the floor was warm and everything. And we just loved it. And that is the end of my video for today. Have a great Thursday.